So in this question, we have graphs. And the first thing we're going to look at is the axes: displacement time, displacement time, displacement time, displacement time. So we might as well do an oizerga to start this out. X, R, G, A. And the origin, we can see they're all 0, zeros. The y-axis is delta x, and the x-axis is time. So the things we can read are displacement and time. The slope is delta x over delta t, which is the velocity. And the area is x times t, which is meters times seconds, which is nothing. So the area has no utility. So we have a body moving in a straight line. The graphs show the variation of displacement with time. So we have a number line. Which graph shows the motion with negative acceleration? All right, so the first thing is we want to try to look at the y-intercept. That gives us a clue. It says it's moving to the straight line. It doesn't tell us what its speed is in the beginning. So we can't use that. But we know that the acceleration, so if this is positive and this is negative, if something is heading in this direction toward the right, it has a positive velocity. And if it's headed toward the left, it's negative velocity. But what about the acceleration? If something is getting faster in this direction, it has positive acceleration. Something in this direction, getting faster, has negative acceleration. So none of the displacements are negative. But what we do know is that there is acceleration. And since the slope of a displacement time graph is the velocity, we would expect to see the slope change. So we need the slope changing. This one shows constant v, so that's out. This one shows constant v, so that's out. So just realizing that a straight line of a displacement time graph is constant velocity allows us to get to 50-50. So now we see this one here. The displacement is getting faster. So we see if the slope is the tangent at these points, it's delta y over delta x, we can see the slope is increasing. That is positive acceleration. What we have here is we see the slope is decreasing. And the way we could look at this is say, let's assign this a number like a slope of 8. Well, this would be less, like 7, like 6, like 5. So even though it's continuing to move in the positive direction, it's slowing down. And we can see now it's approaching like an asymptote. Like this thing is going to eventually, slow down, maybe even stop. And so we have something slowing as it moves in the positive direction, which is negative acceleration.